Today we're talking about proportional relationships, okay? And it says two quantities are proportional if they have a constant rate or unit rate. And so that means it is proportional when all rates are equal. We also know that it is non-proportional and sorry, I have my spelling wrong there. That's an O and that's an R. Backwards. When the rates are not all equal. And notice I have all in there. If some of them are equal, but at least one of them is not, it is still non-proportional. So they gave the example here. We have our price, the total cost of the order, and how many pizzas were ordered. If I do 8 divided by 1, that's 8. And 16 divided by 2, that's 8. And 24 divided by 3, that's 8. 32 divided by 4, 8. 40 divided by 5, 8. So in all of the scenarios here, the price with the number of pizzas, it was always $8 for each pizza. Here it was just that they got 3, so it was 8 plus 8 plus 8. Here they got 5, so it was 8 plus 8 plus 8 plus 8 plus 8, or 5 eighths to get to 40. Okay? When you look at the first example, it says, determine whether the cost of coffee is proportional to the number of pounds. I like to always circle the word proportional in the question when it says, like, determine whether this is proportional. And then I underline what it's talking about right before and what is right behind it. That tells us how we are dividing. So notice, I'm not doing 1 divided by 3, because that would be determining whether the pounds of coffee is proportional to the cost of the coffee. But it says cost divided by pounds. So cost divided by pounds, 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. 12 divided by 4 is 3. So on this one, all of them are all of them are equal, so it is proportional. Then it talks about this part, identify the constant of proportionality. Well, the constant of proportionality is just the constant rate that made it proportional. And what I mean by when I say constant, it's that rate that you saw over and over and over again. Like this, it was 3, then 3, then 3, then 3. So because they were all 3 and it was constantly 3 the entire time, that made it proportional. So the constant of proportionality is the constant that made it proportional, which was 3. So the constant of proportionality is 3. On the next one, determine whether the number of legs are proportional to the number of spiders. So we're doing number of legs divided by number of spiders. So 8 divided by 1 is 8. 16 divided by 2 is 8. 24 divided by 3 is 8. 32 divided by 4 is 8. Now when you look at this, it says if the relationship is proportional. First of all, we have to decide. It is proportional. And you would explain why. I'm not going to take the time to write it out. But the reason why is because all of the rates are equal to each other. They all simplify down to be the same thing. Then it says identify the constant of proportionality. My constant of proportionality is equal to 8. 8 is that constant rate that made it proportional. So its constant of proportionality is 8. On example 2, it says determine whether the distance is proportional to the time. That means we're doing distance divided by time. So 50 divided by 1 is 50, 70 divided by 2 is 35, 90 divided by 3 is 30. Notice it was 50, then 35, then 30, and those are not equal. So that means this is non-proportional or not proportional. Number 2, determine whether the number of ice cubes is proportional to the number of drinks. That means we're doing ice cubes divided by drinks. So 6 divided by 1 is 6, 14 divided by 2 is 7, 22 divided by 3 is 7 and 1/3, or 7.3 repeating. Okay? On that one, it is non-proportional because our rates are not equal. Notice, if it is non-proportional, there is no constant of proportionality. I think it glitched out there for a second, so I want to make sure I repeat that in case you didn't hear it. So if it is non-proportional or not proportional, there is no constant of proportionality because there is no constant rate that's making it proportional. Okay? So on this one, you would tell me it's non-proportional, the rates are not equal, there is no constant of proportionality. On some of them today, it's just going to give you the problem and you actually have to set up the table. So it says Uptown tickets charge $7 per baseball ticket plus, or per baseball game ticket, plus a $3 processing fee per order. Is the cost of the order proportional to the number of tickets ordered? We know what two things we're talking about. It's the cost and the tickets. Well, one ticket is $7 with a $3 processing. That's $10. Two tickets would be $7 plus $7 plus a $3 processing fee. That's $17. Notice, you don't have to pay the processing fee for each ticket. It's just $3 for the entire order. So even when I buy 3 tickets, I pay 7 plus 7 plus 7 plus one $3 processing fee. And 4 would be 7 plus 7 plus 7 plus 7 plus the 3. So if we take those numbers, remember we're doing cost divided by number of tickets, so 10 divided by 1, 17 divided by 2, 24 divided by 3, and 31 divided by 4. Well, this is 10. Then this one's 8.5, then 8, then 7.75. So this one is not proportional, and remember, this is something you'd actually have to write out, but since I'm saying it to you, I'm not going to take the time to write it all out. This is non-proportional because the rates are not equal. Now, sometimes they don't give you in the question the order by saying this. Sometimes you just have to figure out, okay, do I want cost per ticket or ticket per cost? Typically, you're always doing cost divided by whatever item we're talking about. So cost would usually always go on the top. Another easy one to decide is if it didn't tell us on this one, we know we find miles per hour and not hours per mile. Okay? This one says, Mrs. Winters has a punch recipe she makes every year for the holidays. She would like to try to make the punch for a larger group this year. Decide whether the recipe Mrs. Winters, or decide which recipe Mrs. Winters should use in order for the punch to taste the same as her original recipe. So on this one, when we're looking at it, you need to make sure that the ratio for each type of juice is the same, or each type of drink, I guess, that's being added to it. So you have to look at the original recipe. What was the ratio of Sprite to cranberry juice? So if you take 3 divided by 1.5, you see the ratio is 2. That means if we had 2 cups of Sprite, we'd have 1 cup of cranberry juice. So in the new one, we have 10 to 5. That means for every 2 cups, there's 1 cup of this, because 10 divided by 10 divided by 5 is also 2. Same thing, 21 divided by 10.5 is 2. So in all of the recipes, the ratio of Sprite to cranberry juice is the same. Cranberry juice to orange juice, we have to check that as well. And so when you would divide this, you'd get 0.75. That means for every 3 cups of cranberry, we'd use 4 cups of orange juice because that's 3/4 as a fraction. When I divide here, 5 divided by 8, I end up with 0.625, so that one is not the same. And the last one, 10.5 divided by 14, that one would be 0.75. So the one that has the same ratios for all 3 drinks compared to each other would be that last one. She'd want to use drink mix 2 for it to taste the exact same. Okay? Another way to kind of think about this type of problem is you would think about this a lot when you're doing things in art class, like mixing paint colors. If you're trying to get the exact same shade of orange, okay, you might have to make sure your ratios are the same when you go to mix it up again. Even if you're mixing up a smaller amount, because maybe you need less, the ratios have to be the same, or the orange won't come out to be exactly what it was the first time around to match up. The next thing that we're talking about is proportionality when you're looking at a graph. And if we look at our numbers here on this graph, we have 10 and 100. So if you were even just thinking about it as a chart here for X and Y, so our 10 over 100, 30 over 300, 50 over 500, and if I would divide out each time, 100 divided by 10 is 10, 300 divided by 30 is 10, 500 divided by 50 is 10. So I know that this line right here for center B is proportional. That line's proportional. If I look at, for center A, I'd be doing 600 divided by 50, which is 12. And then I'd be doing 500 divided by 25, which would be 20. So already I know this is not proportional because the rates are not the same. Now, there's an easier way to determine this without having to find all of the ordered pairs each time and dividing our y divided by x. Instead, you can quickly tell if something is proportional or not, because if it is proportional, it will be a straight line through the origin. Notice they're both straight lines, but this one goes through the point 0, 0. So we knew that one was going to be proportional. Okay? They have to be both parts. It can't just be a straight line. It can't just be going through the origin. It has to be both. So here are some examples, and I already have this done. I'm going to show you my completed versions just to kind of make the video go quicker. So it says determine whether the cost is proportional to the number of items in each relationship by graphing on the coordinate plane. You will have to do this on your homework, where you will have to determine, and now that I'm looking at this really quick, I ended up putting mine flip-flopped. The cost should have been the Y, and the number of tickets should have been the X. So sorry about that. I flipped them around, but they still come out to be proportional the same and non-proportional the same. So what I mean is I just flipped these. Cost should have been my Y value, and number of tickets should have been my X. Okay? But when you look at them, when you plot your points, it would end up that this one would be proportional because it is a straight line through the origin. This one would be non-proportional because it's a straight line, but it does not go through the origin. And the biggest thing when you go to do these is make sure you don't forget to label, and don't forget you have to add in your numbers here. And notice I counted a little bit differently depending on how high I needed to go. On this one I needed to go 30, so I had to count each line by 2. This one I only needed to go up to 14, so I could count by twos, or that one for every 2 lines. So it's really like 1, 2, 3, 4. The very last thing is sometimes they will ask you to read the graph saying what it means. So explain what the point 0, 0 mean. That in 0 days, the plant will grow 0 millimeters. After 3 days, the plant grew 6 millimeters. After 1 day, the plant grew 2 millimeters. After 6 days, the plant grew 12 millimeters. So like this would be 0, 0, this one would be 1, 2, and this one would be 6, 12. This one I just pulled from the graph. It didn't ask you to do it, but I'm just telling you from right there, that's what that one means. Okay? If you have any questions, let me know and I'll be glad to help.